These are the solutions for the third practice quiz for quiz 2 in the third trimester of Algebra 2. So basically on problem 1, you want to divide backwards to establish a value of b, which is called the multiplier. And when you do so, this dividing backwards, you will get 0.2 for each division. And so that does establish that this does belong to an equation of a times b to the x. So your a is the 200, and then the multiplier 0.2, the value you get is the b value. Okay, so yes, you can say because b equals 0.2 and y equals a times b to the x. So you can establish that. On this here, you're going to go backwards in the x's, and unfortunately you cannot establish a value of b because you get 2, 2, 2, and then you get 3. So a value of b cannot be established in y equals log base b of x. But on the quiz, you can, on both, establish a value of b. So this falls apart again right here where you have the 3 divided by 1. You need that to be a 2, and it is not. Or you need all of these to be 3 is probably the better explanation. Okay, so you have one each of these to do, and okay, so the y-intercept can be found on your calculator's table, and the domain on these is all reals. But before we do anything, establish the horizontal asymptote, and that simply is this value that's added on the end there. And then look at the graph of this. So the graph of this is sitting above -2 when you look at it. 5 times 4 to the x minus 2 minus 2. So when you look at this, it's sitting above -2. And let's just standardize my screen here. So this will be greater than -2, and this will be all reals. And you can get on your table where x equals 0, that is the y-intercept. 0, -1.969. That's good enough. And then the x-intercept is when y equals 0. And so you have a little bit of solving to do here. So you have to get that 4 to the x minus 2 power by itself. So 2 equals 0.5 times 4 to the x minus 2 divided by 0.5. Now at this point, you can just figure out that x has to be 3. And you can also see it on your table that it's 3. Because 3 minus 2 is 1, and then 4 to the first power is 4. Or you could do log base 4 of 4 on both sides. So you'll get x minus 2 equals 1. So 3 is x. So you plot all of these, and you just make sure again that that horizontal asymptote is showing in your graph. I kind of crossed it there. I didn't mean to do that. But that you're getting your graph really close to -2. And then it goes up there. You can get a couple more points. I'm not going to really check them real close. I want to see that you're showing that horizontal asymptote there and that you're getting the correct intercepts when you calculate. Okay, problem 4. Vertical asymptote, you set this equal to 0 and you get 4. And then you just want to know, is the graph sitting to the right or to the left? Okay, so I'm actually going to use the log base in this. 2 of x minus 4 minus 1. Or you can say log of x minus 4 over log of 2 minus 1. Either way. So you can see that it actually cuts it off. It does come down to the right of 4. So this is going to be x is greater than 4 for the domain. It's sitting to the right. That's how you look at it. And that vertical asymptote is there, and it does keep coming down forever. The range will be all reals. And then again, if there is a y-intercept, there is not. You see 0 error. So that means there's not 1. And then the x-intercept, you can let y be 0 and try to solve for x. So 1 equals log base 2 of x minus 4. And then each of these gets the power of 2. Okay, so 2 would equal x minus 4, and then 6 would equal x. You can see that on your table too, that you get 6, 0. And then it's just going to come really close to 4 and then hit there and then go off to the right. But it does continue forever. And you need to state, you need to show that in your graph there and not just stop your graph. The calculator is deceptive in the graphing of logarithms a lot of times. Okay, and then the last problem, basically, it's saying that your interval is undefined from 0 to 3. So everything that's not that, okay, this is where the graph exists. So you have to think of everything that's not that. Everything that's not the 0 to 3. And these are the solutions for practice quiz 3 for the second quiz in the third trimester of Algebra 2.